We have already seen the KNN method for predicting a quantitative response. How was KNN implemented in the regression setting? The approach was simple. To predict an observation response, we use the other available observations that are most similar to it. For a specified value of k, each observation's outcome is predicted to be the average of the k closest observations as measured by some distance of the predictors. With one predictor, the method was easily implemented. How well the predictions perform is related to the choice of k. What would the predictions look like if k is very small? What if it is very large? What would the predictions be for k is equal to n? A picture is worth 1,000 words. For small k is equal to 1, shown in blue line, the model overfits to data. For larger k, the model is smoother, and when k is equal to n, the KNN regression prediction is the mean value. And how do we choose k? We use cross-validation. Now, how can we modify KNN approach for classification? The approach here is the same as for KNN regression. We use the other available observations. They are most similar to the observation we're trying to predict, classify into a group, based on the predictors at hand. And how do we classify which category a specific observation should be based on its nearest neighbors? We use the most popular class of the nearest neighbor as the classification prediction. The KNN classifier can also be used to predict probabilities for a class J as a fraction of the nearest neighbor's points whose response value are J. There are some issues that may arise. How can we handle a tie? We just flip a coin. What would be a major problem with always classifying the most common group amongst the neighbors? If we have an imbalanced data set, in other words, one class is more popular than others, the predictions would be biased towards the popular class. How can we handle this? We'll see how in the following session. Performing KNN classification in Python is done via kneighbors classifier in sklearn neighbors. We first import the module kneighbors classifier. After loading the data and do the usual training test split, we first call the class constructor and define the number of nearest neighbors. We then can use the fit method to train, and finally we can predict and get the score using the .predict and the .score methods. How could we extend KNN classifier when there are more predictors? We need to define a measure of distance for observation to determine which are the most similar observations to the observation we're trying to predict. Euclidean distance is a good option. The square of the Euclidean distance is the sum of the square of the difference for each predictor. But we must be careful about when measuring distances. Differences in range in our predictors could be a problem. A good practice to determine the closest neighbors when the number of predictors is more than one is to first standardize the numerical predictors. And you can even standardize the categorical if you want to include them.